Okay. And we saw that the IoT, depending the way that you're looking for, you analyze the IoT, you have a not different definition, but you have some different focus to explain the IoT. Using this definition is more close to about our course focus. Because, for example, if you're learning IoT, you can learn IoT where the focus is the development of device. For example, you study how to programming, the focus is how to use Arduino or how to use the Raspberry device to programming smart nodes or smart device, okay? There is another approach, for example, to use IoT in network, okay? You study, for example, the network protocols like the LoRa, like the LTE, like WiMAX and others, okay? And there are another approach that we study IoT in architecture way, okay? You think about this, the whole system, the end-to-end system to provide intelligence, okay? Integrate a large number of data to provide insight or to provide intelligent to decisions, okay? This approach is more close to the approach that you use in this course. You study the smart device, for example, yes, you show how to programming the Raspberry. We'll show about, you study about networks, okay? The next class is about networks. We study about LTE, about the LoRa, the Sigfox, and others. However, it's only a very short introduction because to really understand, you need to have the network course, and the network course is in the next semester. But our focus is how to use this set of technologies, bunch of technology to produce very nice systems. It's our focus in this course, okay? It's the things that we study today. And to understand a system like that, it's important to understand the architecture of this, the big picture, okay? What is architecture? When you think about the architecture, you think about the systems or the complex systems. When you think about the complex systems, you think about the systems that is composed by systems. For example, just one example, when you think about the airport, one airport has cameras that record the movements in the ground. You have the park systems to, for example, to see if a park position is free or not. You have the system that the professional, the airline use to control the check-in. You have the aircraft and you have other systems, okay? When you think about the airport architecture, you think like a puzzle where you have small components that you need to connect one to other to produce one service, okay? In the case of airport is to fly to one place to other. My camera is not so good, okay, guys? When she, okay, he's back. No, it's not back. So it's the main idea of one architecture. One architecture is a concept in case of the Internet of Things that you divide the systems by functions, okay? And you organize the components by the function. For example, I believe it's much better the second slide, you have more idea. In our course, you have all the architectures, but in our course, we use the 4-stage IoT architecture. okay? And in using this approach, you divide the system in four stages. Stage 1 is the sensor actuators, the sensor 2, internet gateways, sensor 3, the edge, and sensor 4, the cloud. I explain. Think about, for example, one industry plant, okay? When you have sensors that monitoring, for example, the temperature, the humidity, and other information, and need to send the information to the cloud, where you have the intelligence system that define, okay, you need to replace you need to turn on the air conditioner, you need to turn off one machine, turn on another machine, okay? What you need to do is divide the system by components, okay? The stage 1 is the sensor, okay? Think about the industry. The sensor and actuator in this layer, okay? You have the device that's sensing things, okay? Give me a second. For example, you have the cameras, okay, like that. You have the temperature sensors, the humidity sensors, and other devices that collect information. All the devices that you have in the sensor actuators in the stage 1 is related to collect data. Is the sensor, okay? In this layer, you have another type of equipment that is actuators that you can receive command from the cloud to change the, for example, turn off, turn on, to do things like that. It's the first stage, it's the sensors. The second stage is the internet gateways or data acquisition system, okay? For example, here you have a camera, a very small device that has a lot of constraints. For example, it cannot consume a lot of battery, need to use, it's not a powerful equipment, it's not a smartphone, it's a very restricted equipment, like, for example, a webcam, okay? This device maybe don't have support, for example, to internet. Use a specific protocol to send only the required data. Okay. For example, I have it here. Give me a second. I don't have camera. I just to check to return my camera. Give me a second. I see here. Not yet. Maybe later you will return my camera. So this device is a very constrained device, okay? Don't have a lot of power. For example, your webcam don't have nothing. It's only a camera that records things. Don't provide security, for example, okay? If you connect your webcam directly to internet, your webcam is complete, as I said, is complete unsafety, is complete insecurity because you don't have, for example, a file like your computer has, okay? To provide this type of things, you need the second stage, the internet gateway, okay? In the internet gateway, it's like your router in your home, the wireless router that you have from the internet provider. This router provide, for example, in your home, a lot of services. For example, it provides the internet access, okay? For example, when you are your Alexa, for example, in your home, don't have directly connection to the internet, need to connect with your router, and this router provide internet connection. The second thing that this gateway provide most of the time is security, because, for example, one hacker, if you want to attack, for example, your Alexa system, need to attack first your router, need to transpass the router, okay? It's the things that this layer provide, internet gateways. And this device send the data to the cloud, okay? For one moment, we don't analyze this layer or want to go direct to the cloud, okay? This gateway provides to the data from the sensors is sent to the cloud. And in the cloud, what you have, for example, things that you have a temperature sensor, okay, that collect the current temperature and send to the cloud. For example, in the cloud, you can have a function, and this function, for example, analyze the data, the temperature data, and you have a specific rule. For example, if the temperature is between 27 degrees Celsius to the 30 degrees, is good. If it's outside this range, you have a problem, okay? And you generate alert. For example, in the cloud is one place that you can install this function, okay? Another thing that you can have in the cloud is using machine learning algorithms to detect, for example, trends or to detect patterns, okay? It is in the cloud. It's not here in the internet gateway. The internet gateway has more power than the sensor, but it's a very cheap system. It's a very unpowered system. Don't have a lot of things. Most of the time, send aggregation, measure control, but very simplistic things. Okay? Any questions until here?
No, teacher.
Okay. Again, the sensor actuators is in the plant, it's local, okay? Internet gateway is local too. If you see in your home, for example, if you have a Wi-Fi installed, you have a very high-speed technology, okay? You can send data very fast. But to the internet, it's not the true. For example, you have a Wi-Fi technology, you can have, for example, 56 megabits per second. But your internet service provides only 2 megabits or 10 megabits, okay? Because here, sometimes you need to send the gateway to the cloud, you need to use the satellites where you have very limited bandwidth. The problem is, fix a video camera, okay? A video camera produces at least fit on just it around 64 or more megabits per second. It's a lot of data. And you need to send this data to the cloud, process the analytics, for example, to use the machine learning data, algorithms, for example. It's very difficult because it's a lot of data to send by using the internet. To provide solution to it, first, did you understand the problem? Guys, did you understand the problem?
Sure. Could you repeat it again, please, teacher?
Okay. The question, I try to find you. I cannot see how to see you. Give me a second. I don't know. So my question is, first, this two-stage is local, okay? You have, for example, a very high-speed technology, for example, Wi-Fi. You have a high bandwidth or a big bandwidth capacity, okay? Because it is in your local network, okay? However, For example, here, one camera or one other data system like the temperature measure produce 1,000 of data per second, a lot of data per second, okay? And you need to transmit it to the internet. But the problem of the internet, okay, is you have high speed, but not so high than the local network. The speed is smaller than the local network. The bandwidth is much lower than the bandwidth in the internet. Oh, sorry, the bandwidth in the internet is much lower than bandwidth in the local network. Okay? So what I try to explain is here you have less resource to when you think about the network, okay? You have less resource. For example, you cannot send this amount of data through the internet to the sensor, to the cloud. It's not work. Did you understand now?
Yeah, thank you, teacher.
The problem, it's a big problem because here in the cloud, for example, to machine learning, you require to have the raw data, okay? You need to have the data, or at least you need to have a lot of data to analyze, to use statistical functions to define patterns. But it's impossible because in the middle, you have the internet. You don't have so many resources in the network to transfer this data that you produce here to here. A solution is the edge. An edge is a system or device that has the same models, for example, the same hours that you have in the cloud, but not so powerful. A little, it's a simplest, it's not exactly it, okay, but it's like a simplistic version of the cloud, okay? You have a lot of functions that you have in the cloud, but not so powerful than the cloud, because the cloud, you have a lot of resources. Here, no. You have a device that is close to your sensors, okay? It's very close to your sensors, and this device provide analytics too, like in the cloud, provide pre-processing, and provide other security, okay? And the edge IT, what is the edge IT? It's a device that is close to the users, okay? And that it works like an internet gateway too, but provides other functions. For example, things that you have a lot of sensors that produce thousands of messages per second. But a lot of message is like, for example, things about the temperature. The first second is 40. The second data is 40. 30, things about 33 Celsius, 23 Celsius. The next measure is 23 Celsius. The next measure, 23 Celsius. Do you need to send this data to the cloud? No, it's not required. You can use the edge. And the edge, what the edge does? The first data, the edge sent to the cloud. However, the second, the third, the fourth is the same information. You don't need to send to the cloud. When you send to the cloud again, when you, for example, it happens a change. When this change happens, you send only the difference, okay? You send the first, you send the fourth, and the fifth, and 50. Did you understand? The edge can pre-process the data and aggregate this data to avoid that you transmit data that is not important to have in the cloud. For example, if you don't have the edge, you send, for example, 1, 2, 3, 4 times the same information. But if you have the edge, you can send the first and the 50 when it happens some change. And follow this approach, you can, you can economize a lot of save a lot of bandwidth. Did you understand why?
Yes, so there isn't unnecessary data memory use, no? Like they don't use unnecessary memory with the same data. So they just send one example of the data that it's repeated.
Yes. For example, I agree here. It's very this. The idea is, if you have the edge, okay, the edge a lot of times is the same equipment. Okay, you have the internet gateway. The edge is the same equipment. Okay, the same hardware. Okay, and this data here, what you do first, this device need to have some storage, okay, to save the raw data. Okay. So you receive message 1, you save the raw data. Message 2, message 3, message 4. Okay. When you receive a different data, you save locally, but you send to the cloud. And you save bandwidth because you don't use the bandwidth to send the repeat information, redundancy information. Did you understand?
Yes.
Okay. The edge provide another thing. Remember, the edge it's not exactly it, okay, but for now you can think like that. The edge is a small version or a simplistic version of the cloud. Okay. In the edge, you have analytics like in the cloud. Okay. In the edge, you can apply some artificial intelligence algorithms. Okay. You can apply this in the edge. Okay. And so you use this capability to avoid to send redundant information to the cloud. You only send the required information to the cloud for works. Okay. Using this approach in the first stage, you have more efficient system to use in the IoT. Okay. Any questions?
No.
Now we study layer by layer. The first layer is the things, sensors, and actuators. Okay. Remember, a sensor or actuator is a device that can emit, accept, and process that data over the network. Okay. If you are a sensor, you only emit information. Okay. A sensor only emits, you only send information to the using the network. But if you are an actuator, you can receive command, okay? You can receive, accept, and process data over the network. Think, for example, the air conditioner, okay? You monitor the temperature of the environment, okay? You measure the temperature of the environment step by second by second, okay? In the edge layer, when you see that the temperature change, use, for example, things in the situation. In your environment, the temperature needs to be between 12 Celsius degree and 24 Celsius degrees, okay? And you apply this rule in you can apply in the cloud, but as you're told now, you can apply in the edge. And as you apply in the edge, what happened? You receive the first measure from the device is 30, it's okay. 40 is okay. 25. When you receive the 25, in the edge, you can have a rule that, okay, if the temperature is outside, is an outlier or is outside then the range, you turn on the air conditioner. Okay. Did you understand the example?
Yes.
Okay. So if the equipment has the capability to receive a command, for example, turn on the equipment, it is this sensor has an actuator. Okay. If you only send information to the internet or to the network, is a simplistic sensor. So the sensor can be wired or wireless. Okay. Remember, in the past, you have a lot of wired systems. Okay, but for now, most of the sensor is a wireless. You don't use a wire. So again, the sensors are electronic devices composed of sensitive cells that are able to measure physical parameters like the light fluctuation used for resistor, the temperature used in thermistor, detect flames, sounds, movements, and others. Okay, here you have a list of a sensor device. Another device is an actuator. Okay, an actuator is a device that is part of a machine that is responsible for moving or controlling a system or mechanism. Okay, for example, open a valve, turn on, turn off. Okay, in other words, actuator is an object that can receive command from the internet. And what is a smart object? A smart object is a system that has capacity to interact with other smart objects. For example, if you have, in my case here in my office, I can control the air conditioner by my cell phone. Okay, I don't use the expert to do it. I use my smartphone to monitoring using an application installed in my smartwatch. Okay, and I use the smartwatch in your lamp that's installed in my smartwatch to control my air conditioner. Okay, in this case, my smartwatch, my air conditioner and my smartphone, my air conditioner in my smartphone is a smart object because they can interact one to other. Okay, here you have a list of what is smart object and not smart object. You'll see that not smart is a sensor, is a actuator, is a simplistic sensor. However, the smart object is, for example, smartphone, for example, on Android, because the Android has sensors and actuators and can interact with other objects. Microcontrollers like Arduino, PIC, and Raspberry, and robots and others. Okay. So one example is Arduino device. Who knows Arduino? Who already programmed in Arduino before? Someone?
Yes.
Okay. What you did before, Esther?
I think, well, at least in Prepatec, we worked with Arduino. Like in one semester, we made a project, and also recently, with another of our classmates here, we made a project last semester with a temperature sensor and using Arduino phones.
Oh, nice, nice. And you which type of application you did in Arduino?
Which one?
Which type of application you did in Arduino? One example of application.
Like, well, basically we use it for simple things. We use like to program the LED function in our RGB LEDs and those kind of things. And also like the sensors, I think also could be another application to use.
Okay, perfect. Good. And the Arduino is a microcontroller, is a little harder to program in the Raspberry because the Raspberry is a simplistic computer, okay? Raspberry has memory, has internal memory, has video card, it has a lot of things, okay? For example, Wi-Fi is installed because the Raspberry is a computer. It's a very simplistic computer. Who knows or who did you programming something in the Raspberry before? You choose there or not? Daniel, okay, go ahead, Daniel. What you did in the using Raspberry?
Well, I made a object recognition program and a target for automatically target something. It's
Nice.
like with it was with a camera and a light and a reflective tape, and that's all.
Oh, nice, really nice, Daniel. And the Raspberry is a computer. You can do a lot of power things. For example, I don't know if your operation system did you use. Maybe use I cannot remember the name of the Debian that Raspberry have, but it's a computer. Okay, it's a very simple computer, but it's a very powerful computer. You can do. You can control every port, logic port, but you can do so powerful things like you can do in Arduino. It's nice. If you have this experience, it's very, very nice. Okay. Another one has, okay, Ernest, go ahead.
Yeah, I did something similar to,
I cannot hear. Ernest.
Yeah, sorry, because I was in the classroom and someone had the microphone on. And it could have like a little bit of delay, but what I was saying is that I did something related to also object recognition, especially with TensorFlow, and as Daniel had mentioned. And well, I didn't use a Raspberry for it, but I have also programmed something related to distance recognition, particularly with infrared sensors. They function exactly as Daniel had also mentioned, just with a reflective tape and so on. But yeah, mainly it was for object recognition, particularly, and with the Raspberry Pi, and also a little bit of neural networks, but I didn't finish it because it was too complex for me at that time.
Okay, nice. Thank you very much for sharing for us. Yes, again, it's a very powerful system. Okay, you can do now it's very important to have this experience. And again, the Professor Yepes is working, I believe he's using Raspberry with you at the end of the course. So to understand, and after this video, I will give you a break, to understand what you can do with these devices or what you can do with IoT today, I would like to share this video with you. I just check if I share the audio. This video is nice because it shows a lot of good ideas to how to use IoT technology to solve problems, okay?
Welcome back to Emerging Tech, the definitive channel for upcoming technology that will change the world as we know it. If you're a regular internet user, you probably would have heard about the Internet of Things, or IoT by now. IoT simply describes the network of physical objects embedded with sensors, software, and other technologies to connect and exchange data with other devices and systems over the internet. We now have many of those devices in our homes, helping us regulate our room temperature, humidity, door locks, and many more. In this video, we'll look at the 10 most advanced IoT devices in the world. You'll be surprised by what these devices can do, so make sure to watch the video to the end. Number 10. Wemo Smart Plug. Being able to control the bulbs in your house from anywhere goes a long way in ensuring your house's security and lighting, especially at night. With the Wemo Smart Plug, you can now switch on or off all of your home bulbs from anywhere. This smart IoT product provides users the ability to monitor the lighting of their homes remotely. You can create rules, schedules, and receive notifications. The Wemo Smart Plug also gets insights into your home energy usage. You can use it with both iOS and Android devices, and it integrates with Alexa or Google Voice for hands-free control. Number 9. Enerve React. How many times have you forgotten that your food is still on your blazing gas cooker? You probably have washed your burn pots several times in the last few months. Well, many people didn't end up with burned foods, but a burned house. Preventing fire disasters at home and offices is the exact reason Enerve React was invented. Enerve React is the first device that lets you control your stove from your smartphone. Its combination of electronics and sensors enables it to detect high levels of smoke, natural gas, and lack of human motion in the kitchen. This device can react and turn your stove off when you're not near it. Enerve React also allows you to modulate the burner temperature from your mobile device. With this innovative device, you are surely many steps above home fire disasters and burned foods. Number 8. Bitdefender Box 2. The idea of IoT sounds great until you remember that internet-enabled devices are susceptible to hacking. However, with Bitdefender Box 2, you don't have to worry about the security of all of your IoT devices. Bitdefender Box 2 is a security device trusted by many experts and users for securing homes by protecting all connected devices with a single security solution. It plugs into your router and protects an unlimited number of Wi-Fi and internet-connected devices using Total Security Unlimited. This device offers excellent data protection, providing an out-of-the-box solution that gives its users peace of mind concerning their IoT devices. Number 7. The Amazon Dash Button. The Amazon Dash Button is a consumer goods ordering device that uses proprietary devices and APIs to order goods over the internet. This IoT device can remember important household items like grocery materials, soft drinks, medicines, and others. You can place orders for them when their supplies are running out in your home. It monitors the supplies to check the quantities remaining and places an order at the right time. All you need to do is complete the first order. From that point, it will take up fresh orders unless you have authorized it for multiple orders. Number 6. AdhereTech Wireless Pill Bottle. The AdhereTech Wireless Pill Bottle is a drug bottle that can be used by patients in pharmaceutical and research engagements. With this bottle, patients get customized support and reminders sent to their phone via text message or an automated phone call. This bottle automatically sends data to AdhereTech's HIPAA-compliant system, where it's analyzed to determine how to best support the patient. For example, if doses are missed, patients can receive customizable alerts and interventions. Patient responses to the interventions can also be analyzed. Number 5. Picno. Every farmer knows that getting all the data parameters of the soil and the air is important to their farming success. Picno is an IoT device invented to help farmers tackle the problem of food security by building a network of wireless sensors for growers. These simple-to-use and easy-to-maintain sensors measure key parameters of the soil and the air, which are mixed with other regional data to provide users with the best practices on how to be more efficient at producing food. Current Picno users have shown great improvements in the quality and quantity of their harvests, while also reducing the amount of resources such as fertilizers, water, pesticides, fungicides, and electricity that they use. Number 4. Cubic. Have you ever wished that you could connect almost anything around you to your device so that you can easily monitor them? Then Cubic was specially made for people like you. Cubic is an IoT Wi-Fi device that connects your everyday objects and spaces to the web. This 1-inch cubic structure connects, monitors, and reports real-time data on any object, appliance, and living or office space to your smartphone or tablet. This smart device is consumer-friendly, affordable, and has no baseline subscription fees of any kind. You can receive and monitor data on your mobile device using the free Cubic mobile application. Data produced by Cubic is accessible through open-source technology. That means developers can build mobile apps that use the data which Cubic generates to build new products. There are currently 4 Cubic devices, including Cubic Temp for temperature monitoring, Cubic Feel for humidity monitoring, Cubic Glow for monitoring light intensity, and Cubic Move for monitoring motion. Number 3. Ring Video Doorbells. When someone knocks on your door and you're not at home, what can you do? Well, almost nothing. But wait, how about you answer the door even if you were thousands of miles away? With the Ring Video Doorbell, you can now attend to anyone at your door no matter where you are located around the world. This device is a reliable IoT product, allowing users to answer their door via video interaction from any place using their smartphone. It will also protect your home with its security cameras and double-clad home network security. Ring Video Doorbells also provide motion detection sensors, and its videos are HD quality. It provides night vision all day long so that you don't have to worry about night vision. It comes with a rechargeable battery and high performance. Number 2. SensiMed Triggerfish. Diagnosis and treatment of vision loss and glaucoma are usually tricky for physicians. This is because these conditions usually require constant monitoring to get an actual picture of what's really happening within the eyes. Optimal diagnosis and treatment of glaucoma is the exact reason SensiMed Triggerfish was invented. This continuous ocular monitoring system is a CE-marked and FDA-approved device that provides insights into the ocular volume changes throughout the day and night. This IoT device obtains critical information about the eye at any time of the day and sends the information to a physician. This helps the physician in the diagnosis and treatment of glaucoma. Number 1. Abilify MySight. There have been many inventions for medical practices in the past few years. One of the most notable of those inventions is Abilify MySight, a drug approved by the FDA in 2017. Abilify MySight, which is actually a aripiprazole tablets with a sensor, is the first drug in the US with a digital ingestion tracking system. This combination has an ingestible sensor embedded in the pill that records if the patient took the medication. For those that don't know, aripiprazole is used for treating schizophrenia. So the need for the tracking system is understandable. With it, patients' adherence can be monitored by their healthcare provider. We hope you enjoyed the 10 most advanced IoT devices in the world video. Make sure to check out Emerging Tech's video on 10 real flying cars coming before 2030. Click right here to watch it, because you definitely do not want to miss it.
Did you like, guys? I need to stop in a second. Did you like the ideas?
Yes.
It's nice, no?
Impressive, yeah, like there was a variety and all, and different applications.
Yes, I have a lot of videos. I try to every class show another. It's like the Cisco. No, I believe in the Cisco you have some ideas. Oh, nice. Today I showed this video. I have another small video. In the next class, I try to show another ideas. I have a lot of sites that people publish very crazy ideas how to use IoT technology to support people. The application that you develop in the Reto, my idea is that you publish in the YouTube the results, and maybe in the future you have a new case like you with you did. I believe the IoT is nice because you can do what you think. You need to implement, but if you have a good idea, you can do using the IoT.